There is a bolt orbiting Earth right now, roughly the size of your thumb, moving at 17,500 miles per hour. If it hits a satellite, it doesn't dent it. It doesn't crack it. It vaporizes it. That single bolt carries the same kinetic energy as a hand grenade going off. And there are an estimated 130 million objects like it circling our planet at this exact moment. Most of them are too small to track. All of them are moving fast enough to kill. We've known this was becoming a problem since the 1970s. We have billion-dollar space agencies. We have companies run by the richest men in human history throwing rockets around like frisbees. And yet, in 2026, we are still fundamentally, embarrassingly, spectacularly unable to clean any of it up. By the end of this video, you're going to understand why the smartest engineers on Earth have been beating their heads against this wall for 50 years, and why one specific scenario, one that has a name and a mathematical model behind it, could permanently trap humanity on this planet. But first, you need to understand what we're actually dealing with up there, because it's so much worse than most people realize. When you picture space junk, you probably picture something like a scrapyard, a junkyard floating in orbit, big chunks of metal drifting lazily past each other, occasionally clanking together. Wipe that image from your brain. It's completely wrong. Real space debris is more like a shotgun blast in slow motion. It's a shell of trash surrounding our planet, orbiting at speed so fast that a fleck of paint, a literal fleck of paint the size of a grain of rice, hits with more force than a rifle bullet. In 2016, one of those flecks slammed into a window on the International Space Station and left a chip you can see from across the room. A fleck of paint. There's a piece of hardened glass, roughly 2 feet thick between the astronauts and the vacuum, and a speck the size of a sesame seed cracked it. I remember seeing that photo for the first time and just sitting there staring at it, trying to internalize what that actually meant. We casually talk about space like it's a peaceful, quiet place. It's not. It's a firing range, and we've been the ones loading the guns for 60 years. Here's how we got here. Every rocket we launch leaves stuff behind. Spent booster stages, detached bolts from separation events, frozen droplets of fuel, flakes of paint peeled off by radiation. Then satellites die, either from old age or from getting hit by other debris, and they become debris themselves. Then those dead satellites collide with each other and shatter into thousands more pieces. Each piece then becomes its own bullet, capable of shattering something else. It's a chain reaction. And in 1978, a NASA scientist named Donald Kessler did the math on where that chain reaction leads. He called his paper Collision Frequency of Artificial Satellites, the Creation of a Debris Belt. Nobody read it at the time. It sat in a filing cabinet for decades. But what Kessler predicted has a name now: the Kessler syndrome. And it's the thing that keeps space agency directors awake at 3 a.m. Here's the idea. If enough debris accumulates in low Earth orbit, collisions become inevitable. Each collision creates more debris. That new debris increases the chance of more collisions, which creates more debris, which increases the chance of more collisions. And at some critical density, the process runs away from us. It becomes self-sustaining, a cascade, a chain reaction that could saturate low Earth orbit with so much shrapnel that launching anything through it becomes suicide. Not for a year, not for a decade, for centuries. Every satellite we depend on for GPS, weather forecasting, banking, phone calls, Netflix, and military intelligence would eventually get shredded. And any new rocket we tried to launch would just add more shrapnel to the swarm. We'd be locked out of space by our own garbage. And here's the terrifying part I want you to sit with. We might already be past the tipping point in some orbital bands. Some models suggest certain altitudes are already Kessler positive, meaning the cascade has technically started. It's just running in slow motion. Nobody knows for sure. That's how bad our tracking capability actually is. Which brings us to the question that seems so obvious it feels dumb to even ask. Why don't we just clean it up? Grab a big net, send up a garbage truck, scoop up the trash, bring it home. Problem solved, right? If only it were that easy. And this is where the story stops being about physics and starts being about heartbreak. Let's start with the speed problem. Everything in orbit is moving somewhere between 17,000 and 28,000 miles per hour. That is not a speed you casually match. To grab a piece of debris, you have to launch a spacecraft, burn enormous amounts of fuel to catch up to it, and then match its speed within a few centimeters per second. Because if you're off by even a little, you're not grabbing it, you're getting shot by it. And it's not one piece. It's millions of pieces, each on its own orbit, each at its own inclination, each at its own altitude, spread across a volume of space roughly 45 billion cubic kilometers, a region so vast you could fit every ocean on Earth inside it more than 30 times over, with room to spare. Imagine trying to catch every single mosquito in North America, one at a time, while blindfolded at supersonic speeds, using a spacecraft that costs more than a small country's GDP. That's roughly the difficulty level. Then there's the political problem, which is somehow even worse than the physics. Under international space law, every piece of debris up there technically still belongs to whoever launched it. Meaning, if the United States wants to remove a dead Chinese satellite, that's not cleanup. That's legally indistinguishable from stealing a foreign government's military hardware, which, depending on the day of the week, could be considered an act of war. So most active debris removal missions are stuck in this weird diplomatic limbo. Nobody wants their satellite touched by anyone else. Nobody wants to admit their old junk is a problem. And nobody wants to give another country a demonstrated ability to grab satellites out of orbit, because whatever tech grabs a dead satellite can also grab a live one. Space cleanup, it turns out, looks exactly like space weapons. That's not a bug. It's the same technology. And I'll come back to that in a second because it leads to something that genuinely blew my mind when I first learned it. Then there's the size problem. The tracking systems we have on the ground can spot debris down to about 4 inches across. Anything smaller than that is invisible. We know statistically that there are tens of millions of pieces in that too small to track, big enough to kill category, but we can't see them, we can't predict where they'll be, and we can't dodge them. Every satellite operator in the world is essentially playing Russian roulette with a gun they can't see. Now here's the wild part. Some of the proposed solutions to this problem sound like they were written by a 14-year-old on a Red Bull binge, and yet they're being seriously considered by major space agencies. Ground-based lasers that would zap debris and nudge it into a decaying orbit until it burns up in the atmosphere. Giant magnetic tethers that would drag conductive junk down by generating currents against Earth's magnetic field. Aerogel foam clouds released in orbit to soak up small particles like a cosmic sponge. Harpoons, actual harpoons, fired from cleanup satellites to spear dead spacecraft and drag them down. The European Space Agency actually tested a harpoon in 2019. It worked, and yet almost none of these technologies have scaled up because every single one runs into the same wall: cost, politics, and the sheer scale of the problem. Cleaning up one piece of debris currently costs somewhere between $10 and $100 million. Multiply that by even a fraction of the objects up there, and you're looking at a bill measured in trillions. Nobody wants to pay it. Nobody wants to admit it's their trash. And the companies filling orbit with new satellites right now, SpaceX alone has launched over 6,000 Starlink units and plans to launch tens of thousands more, are moving faster than any cleanup plan could possibly keep up with. Which brings me back to that thing I promised would blow your mind. Remember how I said cleanup tech looks identical to weapons tech? That means the incentive structure for the world's biggest space powers is genuinely backwards. Nobody wants to be the first country to develop and deploy a functioning debris removal system, because doing so would essentially announce to the world, we can now yank any satellite out of orbit at will. That's not a cleanup program. That's a strategic weapons capability with a friendly PR wrapper. And this isn't hypothetical. In 2007, China deliberately blew up one of its own dead weather satellites with a missile, an anti-satellite weapons test, and that single event created over 3,000 pieces of trackable debris in one afternoon. It's still, to this day, the largest debris-generating event in the history of spaceflight. Most of those fragments are still up there. They'll still be up there 100 years from now. Then in 2021, Russia did the same thing. Blew up one of their own defunct satellites with a missile. Created another 1,500 pieces of trackable shrapnel. The debris cloud passed so close to the International Space Station that the astronauts on board had to evacuate to their escape capsules and prepare to abandon ship. Not once. Not twice. Repeatedly, for days, every time the orbit brought them back into the cloud. Real astronauts. Real evacuation. Because a country wanted to test a weapon. So we're locked in a slow-motion tragedy of the commons. Everyone knows the problem is getting worse. Everyone knows someone has to act. And every actor has a strong incentive to let somebody else go first, because whoever goes first also announces to the world that they've built a satellite killer. Meanwhile, the debris keeps multiplying. Every collision breeds more. Every launch adds more. Every weapons test adds thousands. And every year we wait, the math gets uglier. Here's an obscure fact that made me put down my coffee the first time I read it. In 2009, an active American communications satellite called Iridium-33 collided with a dead Russian satellite called Cosmos 2251. It happened over Siberia at a closing speed of about 26,000 miles per hour. The collision instantly created over 2,000 pieces of trackable debris and probably tens of thousands of untrackable ones. Every one of those pieces is still up there. Right now, 16 years later, still orbiting, still capable of shredding anything they touch, and some of them will remain in orbit for centuries before atmospheric drag finally pulls them down. One collision, one afternoon, a permanent scar on our orbital environment that will outlive everyone watching this video. And here's the part that really keeps me up at night. We are currently in the middle of the largest space launch boom in human history. More rockets went up in 2024 than in any year since Sputnik. Mega constellations are being deployed by the tens of thousands. Private companies are racing each other into orbit with no meaningful regulation and no requirement to clean up after themselves. We are right now sprinting toward the exact conditions Kessler warned us about in 1978. So what happens if the cascade actually starts? If we hit the tipping point? The scary answer is that we might not notice it right away. Kessler syndrome isn't a Hollywood explosion. It's a slow-motion strangling. Satellites start failing a little more often. Insurance premiums for orbital hardware start climbing. Launches get riskier. GPS accuracy starts degrading. Weather forecasts get worse. Global communication starts hiccuping. And one morning, a few decades from now, some kid asks their grandparent why we can't just fly to the moon anymore. And the answer is going to be something like, well, we used to be able to. Then we filled the sky with knives. There's still time. Probably. The math says we can still fix this if we act in the next couple of decades. But every year we wait, our window shrinks. The final irony is this: humans spent hundreds of thousands of years staring up at the sky, dreaming of getting off this rock. We built the rockets, we escaped gravity, we put footprints on the moon and machines on Mars. And now, 60 years into the space age, our biggest threat to a future among the stars isn't distance. It isn't physics. It isn't even money. It's our own trash.